Hello, today we are going to talk about Siemens S7-1200 series PLCs. I have a few of them here, and also I have a communication module and I/O modules on display. This is probably one of the most common versions of the S7-1200 series PLCs, the 1214C DC-DC-DC version. This one here is 1215C, and this one is the 1214FC, also DC-DC-DC version. This one here is also a fail-safe PLC. So we are going to take them apart and look what's inside of them. We're going to start with the 1214C version. This one also has a signal board here. You probably don't see those signal boards every day. These are not too common, at least I haven't seen them quite often. But this may be quite useful sometimes to expand IOs or expand communication capabilities. For example, you can have the RS485 connection through here, or you can add an extra battery for the real-time clocks of the controller with the signal board here. So let's start taking this thing apart. We're gonna start with removing the signal board. It clicks and pops out. The signal board itself is, well, it's not the most difficult part, or not the most complicated part here. It has the connection pins and also a microcontroller here, which probably is taking care of the communication with the PLC. And also we have a circuitry here, which is the analog output circuitry, because this module is analog output, 12-bit module. And this here probably is the digital to analog converter. So that's kind of a little bit funny thing here. Let's put that aside and focus on the PLC itself. So this PLC has one Ethernet check. It has inputs, outputs, digital, and it has analog inputs. Plus, it has some connections for the power supplies. An SD card, kind of a holder or SD card slot here, and connections for the expansion modules. On the right side, we have expansions for the IOs. And on the left side, we have expansions for communication modules. To open this PLC, we can just use our fingers to pry open these little tabs here. When we use fingers, we don't usually scratch the plastic, and it's quite safe to open this cover up. Now I'm having some problems. Okay, it popped out. So this is the top cover. Under the top cover, it has some clear plastic that is used to direct the LED signals to the front of the cover, so we can see the statuses of the I/O, status of the PLC, and status of the Ethernet connection. The LEDs are here on the board, shown here, here, and here. The board itself, this is the main board, which has the CPU and probably the memory modules here. It has communication some chips here for the bus, the expansion bus that expands the digital and analog I/O, and it has a bus connector here for the communication modules. This chip here probably takes care of the Ethernet connections and maybe takes care of the I/Os, or the communications on the left. What else is here on this board? We can see there is a power supply section here, probably at least, which I think converts the 24 volt signal to 5 volt. So we can supply the chips on this board. So this is basically the motherboard, the main board. To open it up or see what's under it, kind of have to be careful and start taking it off from one side to release it slowly, and being careful. We're going to remove this board from the top. Connecting this board to the board here, we have some pin connectors here and here. On the side of this board, there are some more chips and circuitry that is needed for communications and for the controller itself. For example, here is the Ethernet connections and necessary parts for the Ethernet. Here probably is something to do with the power supply. This connector here probably is used for the I/Os, because the next board we have is the I/O board. And this connector here is distributing the power, 24 volt power. So let's put this board aside and look at the I/O board. So the I/O board here, we can see that we have the outputs and the inputs here. We have digital inputs here and digital outputs here. Plus we have two analog inputs here. Also we have the SD card slot. This board, the idea of this board is that the main board can be actually supplied with power totally separately from I/O. So the I/O through these chips here, these probably are opto-isolators. Through these chips we isolate the I/O from the main board. So we isolate the outputs and we isolate the inputs from the main board. The reason to do that would be to have electrical circuits built up, so when we lose power, we have a battery, for example, that supplies power for the main board. The I/Os may be switched off because of power loss. Why would we want to power the PLC in case of power loss? Maybe we want to use communications to send out distress signals or distress calls, alarms that something has happened, the power has been lost, something has happened. Please attend the system and figure out what's going on. So we could do that. And also, if we separate the main board from the other circuits, other electrical circuits, we can ensure that if something happens with the I/O, if we have some kind of electrical spikes or whatever noise, current spikes, voltage spikes, we will not kill the motherboard. That's one of those reasons why to use separate power for the motherboard and IOs. And that's the reason we have, as you can see on the top cover, we have a separate negative terminal and separate negative and positive terminals for the outputs and for the inputs. So these circuits can be electrically totally isolated circuits. Isolated from the motherboard, isolated from the outputs, isolated from the inputs. These can be separate. Now underneath this board is a power supply. So this probably filters and regulates the power that goes into the motherboard and that comes out from this port here. It has the 24 volt DC output. So probably this gives the juice for this output here. I'm not sure if it's isolating the input from the input power from the internal power. I'm not sure of that. But this may also be true. We have to check this later in some future videos or episodes. But anyway, the power supply. The 1200 series PLC is interesting because it has some PLCs that can be directly connected to mains power. For example, 230 volts AC can be applied directly to the PLC that provides power for the PLC. So usually we have 24 volt DC, but sometimes we can use 230 AC. And the difference between the controllers, PLCs, is actually only this board. So this board converts the 230 to 24 volts. So let's put this one aside now. And now we can compare the 1214 to 1215 series PLC. So let's move things around now. Let's put this on the side. Let's put this one on the side. And let's take a look at the 1215 DC. So opening this thing up is basically the same as before. Using my fingers, I can open up it from the sides. And the front cover pops up. This controller has two Ethernet ports, and if I remember correctly, this also acts like a switch. Therefore, we can expand our network through these ports. So one Ethernet cable can come in from one of those ports and it can expand to another PLC, for example, or expand the circuit from there. So if we compare the motherboards now, the motherboards are quite similar, but we can see the memory chips are in different locations. So for example, here they are in 90-degree angles, here they are parallel. This part here is quite similar. We have the power supply here, and we have the communication parts for the I/O connections. But what's different is the connections to the communications modules, and we can see the Ethernet part of this board is also a little bit different. And this board has a lot of room. compared to the other board. It has some blank spaces that are not filled, because physically this PLC is larger. Now let's try to take this top board off. The idea here is basically the same as before. It has two connections. It has the I/O connection and the power connection. On the sides, what's different under those boards? Not much really. The components are in different places, and we have double the components for the Ethernet ports. And we have more room on the sides, on the underside. So these are the motherboards. The I/O board, as we can see, the digital outputs are basically copied. So even the layout of the outputs is copied from the regular model. Not the regular, the 1214C model is basically copied directly to here. The inputs are a little bit different. The isolators here on top are in different places. Probably some of them are under the board. And we also have circuitry for the digital inputs and outputs. What's also different is the size of that capacitor here. This capacitor is probably the capacitor that keeps voltage and keeps power for the RTC clock that keeps time and date for the PLC. So the real-time clock is probably supported or supplied by this capacitor. So if this capacitor runs dry and runs out of voltage, we lose date and time data. So the I/Os, power supply is basically the same. The components are in different locations, but they seem to be the same components. This 1215 board is actually quite a bit smaller than the board for this 1214. The 1214 CPU is the oldest of the bunch here. This is the CPU that's around 1 year old. And this one is a few months old, probably. Oh yeah, I almost forgot. So you can see that this board, I/O board, has those screw connectors here. This one doesn't. Those screw connectors can be taken off. So if you have a situation where you have to replace the PLC, you don't have to screw all these connectors open, take the wires off, replace the PLC, put all the wires back on and screw them tight again. All you can do if you're replacing the controller with exactly the same model, just put your screwdriver here in the slot. There are the specific slots here, you can see. And use just a little bit of force to push the connector outwards. And it comes off usually easily, but of course the 1215 connector is a little bit larger. No, it's the same. The larger connector is a little bit more difficult to get off. And the bottom connector comes off quite easily. If you're using too much force, you're doing something wrong here. So that's how you can change the PLC without taking all the wires off from the PLC. So that one was the 1215C DC. Now let's try to put that one aside and look what's different between the regular models and the failsafe model. So first of all, this PLC also has the covers on it. To get those covers on, just pull on the cover towards yourself in this example, and it comes off easily. Again, just pull it up, and it comes off easily. Again, we are doing the same thing as before, trying to get our fingers behind those little clamps here. Oop, and it basically everything just jumped off. Okay. Right. So, as we can already see, this model doesn't have a separate power supply. And that's interesting. Where's the power supply? As we can see, the power supply is on the bottom board, or the middle board, if we talk about other PLCs. The I/O board also has the power supply then. Okay. The top board, motherboard. If we compare the motherboard to the other ones, we can see that it has the most similarities with this 1215 series board. The layout of the chips is basically the same. This part here is also basically the same. The power supply here is also almost the same. What's different is of course the Ethernet part. And the Ethernet part kind of looks similar. No, it even doesn't look similar to this one. It's different. But it has the most similarities with the 1215. And what's the interesting part? If we compare all of these boards and the numbers on the chips have the same numbers. That means that the CPU actually is the same for all those three boards. The CPU itself is actually the same. So there is no difference in that in there. Okay, that's interesting. That means that CPU itself is no different. Fail-safety does not come from the CPU. Also, because the boards look the same, we can also tell that the I/O, for example, the inputs here and the outputs here are the regular inputs and outputs. These are not the safety inputs outputs. To get the safety out of this controller, we need to use separate safety I/Os, safety I/O modules here that expand our CPU. On the CPU, we have the regular digital inputs, outputs, regular analog inputs. If we separate this board, we can see the power supply, which basically has the same components as the other power supplies, and we can see the I/O. The I/O is a little bit different. It has some similarities with the 1215 model, but the outputs are completely different to all of those boards, because some of the transistors are on the bottom side because of the power supply here, or the power module here. Why is this power module here? I don't know, but I can just make assumption that maybe they tried to eliminate or try to minimize all those pin connectors, because every connector has a potential to fail. Maybe through vibrations, maybe through corrosion, or whatever else the reason these connectors may fail. So maybe they just wanted to be sure, or more sure, that the motherboard gets the power. But the real reason, I don't know why they did this board or made this board like that. I don't know. And let's try to put this back together. All the pins lined up. This one is good. I'm putting this back here. Let's put together the 1214 model. And let's talk about the expansion modules. The communication modules and the I/O modules. But first, let's put this one back together. So the pins line up. Yeah, it seems so. This one should be fine. I really have to test those PLCs later on if they still work. No, this one is put back together. So, using the PLC with the expansions. First of all, let's use a rail to mount the PLC on to. For mounting the PLC on the rail, basically you just have to put the top part of the controller on first and then the bottom part, and it clicks on. To get it off, you have to release the lower tab, and usually it ends up in this position. You can reset it by just pushing it back in. So let's remove this. Let's make some room. So the top first and then bottom. Okay, so something's wrong. What am I doing wrong? Top first and bottom. And it clicked on. Yep, all good. The I/O modules go on exactly the same. Top first, then the bottom. Click. To connect the I/O module to the PLC, there is a tab here. You have to push it in with the screwdriver and push it left. It also has a little tab here that grabs the PLC, so it makes quite a secure connection. But getting it back off sometimes is a little bit of a struggle. So also we have to make sure that the PLC doesn't have a cover here, like this cover here. We can remove this cover just by using a screwdriver. So let's put these back together, push this in and left, and now they are connected. To get it off, push it in and right, and they are separated. That easy. To connect the communication modules, just try to... I already made a mistake here. I have to take this cover off. Make sure you don't have the covers on. And now you can gently push it towards the PLC and make the connection. And removing this sorry, takes a little wiggle, and it pops off. You can change the I/O modules and take them off just by releasing this clip here and then taking them off from the bottom, and they come out in the same direction here. You don't have to move anything around to get these off, but you have to move the PLCs and everything on the side to get the communication modules off. The I/O modules themselves also can be taken apart by using these tabs here. And using the tabs on the other side, maybe just help a little with the screwdriver, and the cover pops off. Underneath we can see the connector, and that's basically just a bunch of pins that slides on and off. And the connector down there. And it also has the layered construction. For some reason these layers are not separating. I have probably some errors in the construction here. Some tabs are keeping this from separating. Anyways, we could release the first two layers. There are some clips here that keep it from separating. We have to put them back together later. And we have the main boards here. So basically these boards just have the I/Os. For the example, this is this module was the module for 8 inputs and 8 outputs. So it has basically the same components as the motherboards had for the I/Os. It also has a communication chip here that communicates with the I/O bus and also gives us the signals for the I/O states. So this is the I/O module. Let's look at the communication module. When the I/O modules are also constructed in layers, just like the motherboards, then the communication modules, or what I'm trying to say, the layers are horizontal here, but they are vertical on these. So let's try to get this thing open. This is a little bit trickier to get open. It's a little tighter and it takes a little bit more force to open this. And that's the communication module. It has the vertical layers. And that's the communication bus coming from the right side. It's transferring from this board to the other board through here and continuing from the left here. So you can connect 3 communication modules to one PLC. And you can connect 8 I/O modules to one PLC. Well, I just have to put everything back together now. And I hope you had fun learning what's inside the PLCs. At least I had fun. I had quite interesting revelations about the failsafe module. It kind of basically is the same as the others electrically. Not too many differences here. That's interesting. So probably the fail-safeness of this module comes from the hardware or the software that's on the chip. Anyway, I had fun. I hope you had fun. And let's see you in the other videos. The next videos. Thank you for watching.